Welcome to the CircuitPython Show. I'm your host, Paul Cutler. This episode, I'm joined by Abby Bergman and Esha Patel. Abigail J. Bergman is a doctoral research assistant for the Developmental Technologies Research Group at Boston College. She completed her Bachelor of Arts in Psychology at Brandeis University and her Master of Arts in Learning Engineering at Boston College. Her interests include design-based research practices related to engaging young learners in science, technology, engineering, art, and mathematics. She is currently pursuing her doctorate in formative education at Boston College. Esha Patel is a graduate student at Boston College in the Learning Design and Technology program. She completed her Bachelor of Science in Elementary Education and iSTEM education at the College of New Jersey. Previously, Esha taught middle school science and engineering in New Jersey. Abby and Esha, welcome to the show.
Thanks so much.
Glad to be here.
You were both students of Professor John Gallaugher, whom I had back on the podcast when I was just starting back in 2022. Abby, tell me a little bit about his physical computing, interactive art, robotics, and tech for good class, and your motivation for taking it.
Yeah, so his class is really unique in that it's a flipped classroom. So all of the lessons are done at home for homework. And in class, everything is a challenge or an in-class activity that really puts those skills that you did at home to work. And so it's a really different classroom atmosphere. It's in the BC makerspace. So it's not in a typical classroom setting, which makes it really special. And my motivation for taking it, so I'm a PhD student at the School of Education at Boston College, where I'm specifically interested in making and physical computing and what those opportunities to do physical computing can do for young children. So I'm part of a project right now, and I knew a lot about making. I didn't know as much about physical computing. I did maybe one robotics activity. I don't think I touched anything about circuits or electricity since maybe high school physics. And so it was a great, really immersive, deep learning experience, which made me so happy that I had taken that class.
Esha, what interested you about the class?
So I also, similar to Abby, don't have much computing experience. As a former engineering teacher, I did kind of dabble into Scratch Junior and regular Scratch for my students, but not so much of actual Python or anything like that. C++, never touched it. But I wanted to see what the course had to offer because it was an introductory course. The course title literally says that it's meant for people who are new to coding, which was me. And I love creating things. I love making. And I did that with my students in my former classroom. So I took the course to see what it would be like. The flipped classroom was new to me. I've never taught that way. I've never been in a classroom that way. So I was kind of scared with the concept, but I like the idea of being able to control when I can watch each video and do each challenge on my own pace than just all in one 3-hour class period or something like that.
So you both mentioned that you didn't have a lot of experience coding prior to taking the class. What kind of surprised you about the class and the coding part of it?
I think for me, my coding experience had been about statistical analysis. So it was really applied and it was very plug and chug using the same lines of code, not really thinking about what the functions were, but understanding kind of more the math that's being done with different libraries. I think something that I really loved was like the hardware software integration too, being able to pull in these different libraries that did things in the real world that I could see and touch made it make sense in a different way to me because of how tangible it was. So I think I had a feeling that might happen just given the nature of the class, but it was still a totally different thing to experience it in person and really made coding more like a living physical thing to me, which was great.
For me, I guess I got stuck on the concept that CircuitPython, at least, or any coding language, is another language that I'm learning, but not in the traditional sense where you read, listen, write, and speak and all that kind of stuff. So I really honed in on that, and that kind of made it harder for me. And then once we started doing design challenges, I stepped back and I realized, okay, I should take this step by step And Professor Gallaugher wants us to create projects and code for those projects in things that we are comfortable in. So instead of me trying to learn a brand new language all at once, I focused on just seeing what my interests were. And a lot of that was sensing technology.
Can you give me an example of some of that technology?
Yeah, so we did, my partner, Jennifer, she's a international exchange student from Germany. She went back to Frankfurt now. We made this interactive hopscotch that kind of similar to a distance sensor, but not really, uses a sensing kind of technology to see when a object, or in this case, feet, are sensed a specific range. And we tried to use various different sensors to see what would work for us. We used an IR break beam sensor to like kind of break the sensor, and that was the technology that we used.
Tell me a little bit more about the project. How long did it take to build, or what were some of the challenges that you had to overcome in building it?
Yeah, of course. We started about mid-October and we finished about end of November-ish. It was definitely a prototype. There's more space to grow. We created 7 individual squares. So imagine a hopscotch, but you're able to take those squares apart. And we used regular black yoga mats, and we cut them into like a square shape and put dowel rods in between to hold the mats in place. At the corners of each of those squares, 2 corners, we put the IR break beam sensors. At a diagonal, it was better than side by side. That the diagonal worked best. And we glued neopixel strips to the inside of the dowels. So like it would kind of look like a concave effect almost. And we used a Raspberry Pi Pico to create a very simple sensing code using the Adafruit animation rainbow chase. So when the break beam was broken, when the IR break beam was broken, it would fill the neopixel strips with the rainbow chase animation. And the second it was unbroken and the object or foot, whatever was being used to break the beam, was gone, the strips will flow black or just look turned off essentially. And the idea came from just like being in the park one day, seeing some kids playing hopscotch, and I'm like, I wonder if we can make this similar to like that Dance Dance Revolution kind of tile thing. And Jenny and I got to working and we came up with the idea. I have an Instructable page about that too, that if you would like to use to share with people.
Oh, that's great. Yeah, I'll definitely link to that in the show notes. Abby, did you have a favorite project or design challenge that you worked on?
Yeah, as Esha was talking, I was thinking about my Tech for Good project. So the final project that we do. At the time I took the class, it was our final project. Actually, that's not right. So, it was our second to last project. But for the Tech Tools for Good project, we all had to create different prototypes for the campus school at Boston College. In the campus school on our campus, and it's specifically for students of a pretty wide range of ages with complex disabilities, many of whom have different visual impairments as well, in addition to other health challenges. And part of our design challenge was to make something that either brought their learning to life, made their lives easier, made teaching easier. And as an education student, this made me so excited. I wanted to make something for younger learners. I wanted to make something soft. I'm a big crocheter, fiber arts person, and I made a very hungry caterpillar. I crocheted the whole body. I put in all the hardware elements. I used Pico. I think I used a Pico W for it, but I could have just used a regular Pico, and added a RFID sensor into the head. And on the outside, there were also these pieces of fruit that you could feed the very hungry caterpillar. So in the book by Eric Carle, the hungry caterpillar has 1 apple, 2 pears, however many oranges, cherries, etc. And I also sewed in Christmas lights into it as well that I programmed. So I had these acrylic pieces with stickers of the fruit and RFID stickers on the back as well. So when you fed the caterpillar, you could hear it, a voice say 1 apple, 1 red light would show up. Then on and on. So when you fed it the last fruit, all of the lights showed up and you could hear the whole story, which was really fun to make. Definitely challenging of putting the like sewing it together, crocheting it. I had a lot of soldering issues, so it was mostly durability, but it was really fun to figure out the RFID.
Did you get the opportunity to see it in action with one of the students?
Not yet. And so part of the reason for that is so many failed solderings that would fail inside of it. So I've had to resew it, reattach it multiple times.
I think everyone who's made a project has gone through that.
Yes.
I have to agree. For the hopscotch, we had to solder pin-to-pin wires to go around from the breadboard to the brake beam sensors on the other side. And, people would think, oh, coding is difficult. Oh, measuring all this. No, soldering was the most difficult thing because it really requires the right nozzle, the right hand movement, and sometimes patience. And when you're grad students, you're losing patience at times.
Yeah, and when you're soldering something that goes into like a object that's supposed to be held and played with, then you have you need it to be flexible and you need it to be sturdy, and that's where I had the failure points.
Speaking of like the differences in the two projects, that's the beauty of Professor Gallaugher's class. You have the opportunity to create something for others as the campus school, and like my partner and I, we created a tic-tac-toe board. You have something to create, opportunity to create something creative. And for us, it was called the Festival of Lights. So it really meshes, personality, service, all kinds of things together.
Tell me a little bit about the Festival of Lights.
So that was a new concept for our semester. I took the class in fall 2025. He kind of took the art project and that he used to do and kind of combined it to create this Festival of Lights where in this prototyping phase, he basically said, we want to showcase to Boston College that we are able to create these amazing lit up structures. And there's no like strict rule of how it was supposed to be. So our Festival of Light project was the Hopscotch. Somebody else created with a stoplight that goes like red light, green light kind of way. Another person created a jukebox. Somebody else created a Minecraft brick. Professor Gallaugher thought somebody would even put lights around some of the buildings and things like that. So there was huge scales and super small scale projects, but it was something new and I hope he continues it for the spring semester. It was fun.
What advice would you have for someone thinking about taking the course?
Something that comes to mind immediately is the match between imagination and technical skill was often frustrating for me. And not so much the circuitry skills. I felt very well prepared there. I felt like Circuit Python, especially, there was such a wide range of tools and resources available to make the software element come to life. I would say the harder part is the fabrication piece of, needing to, if you have CAD skills or not, if you have access and time for the 3D printers. I think everything, which we do at Boston College, everything fails 3 times before it works. And when you're working on a semester timeline, you just have to move on. So I pivoted a lot in the class. So I would say having flexibility and being able to thinking big at the start and then carrying over your skills versus idea match is a big learning point that I would say.
I would agree with Abby about the flexibility for sure. I would say if you feel intimidated by, trying something brand new such as coding, you have to take baby steps with it. And that's the beauty of the flipped classroom. You're able to pace yourself as you go through each video lesson, each design challenge. You're able to, go at whatever pace. Some weeks might be faster, some weeks might be slower, depending on how comfortable you are with whatever topic is being covered that week. And most importantly, just have some patience, because when it comes to making, a lot of the times you want to quickly get a prototype in or quickly finish this line of code, but some designs are just not made overnight. It takes a while to finally develop a proper prototype of software and hardware.
Patience is great advice. Abby and Esha, thanks so much for coming on the show.
Thanks for having me.
Thank you.
Thank you for listening to the CircuitPython Show. For show notes, transcripts, and links to Professor Gallaugher's course and YouTube channel, visit www.circuitpythonshow.com. Until next time, stay positive.